So in this problem, you're being asked to tell whether this is a rational or irrational number. Now, when you look at this problem, you see that there's a square root symbol. And normally when we see a square root symbol, we think, well, it has to be irrational. But the first thing you must do is you must see if you can simplify this expression. And what that means is, if I take the square root of the numerator and the denominator, would that change it? Will it still leave a square root in the answer? So we're going to first take the square root of 4. So we can break this up into two separate square roots. The square root of 4, the square root of 9. And then we're going to simplify this and see if the final answer is rational or irrational. So the square root of 4 is 2 and the square root of 9 is 3. Now our final answer is a fraction, 2/3, and of course we know 2/3 is rational, so the answer for this one is rational. The sum of two numbers is 82. Their difference is 24. What are your two numbers? So the first thing we're going to do is set up two equations. The first sentence, the sum of two numbers is 82. We're going to let x plus y represent our two numbers, and we're going to set them equal to 82. Remember, we're doing addition because it says the sum. The second sentence says their difference is 24. So once again, we're going to set this equation up using the subtraction sign for difference and set it equal to 24. Now, since we have two equations and we have both of our variables on the same side, we notice that one of our variables, which would be our y, are opposite each other. We can use the elimination method. So what that means is we'll now add up each column. So when we add up our x column, x plus x is 2x. Our y column will cancel out because they're opposite each other. And then, of course, 82 and 24 gives us 106. From here, we're going to solve for x. So when I divide both sides by 2, I get 53 for x. Now, if I know 53 is x, I now need to solve for y. So basically what I'm going to do is I'm going to come here and subtract 53 from 82. And when I subtract 53 from 82, that's going to leave me 29 for y. So x is equal to 53 and y is equal to 29. If you want to check your answers, of course you go back and add 53 plus 29 and see if that gives you 82. And then of course, if you subtract 53 from 29, you want to see if that gives you 24. That is how you check your answer. Mrs. Hung operates a soybean farm. She buys many supplies in bulk. Often the bulk products need to be custom mixed before Mrs. Hung can use them. To apply herbicide to a large field, she must mix a solution of 67% herbicide with a solution of 47% herbicide to form 42 liters of a 55% solution. How much of the 67% solution must she use? So the first thing we want to do is we always go to the question first because the question tells you where your variable will be. So we want to know how much of the 67% solution must she use. In other words, we're trying to find out how many liters, okay, of that 67%. So what I'm going to do right now is I'm going to just kind of underline everything that's given. So we know she's going to mix 67% solution. So what a mixture is is an amount of a certain solution added to an amount of another solution to then create something new, basically. So we're going to first begin by mixing two things together. And I'm going to underline these two things. So we have a solution containing 67% herbicide, and we have another solution containing 46% herbicide. Now what I'm going to do over here to the side is show how it's going to be set it up. So we have the two things we're adding. We're adding our 67%, and what I'm going to do, because remember with percents we're going to change them to decimals, so 67% of herbicide multiplied by the liters, and in this case we don't know how many liters because that's our question. So we're just going to multiply that by X. We're going to put an X there, okay? Now it says we're going to add that to our 46% solution. So we're going to add this to our 46% solution. And we need to know how many liters we have here. So at this point, we really don't know how many liters. So I'm going to leave that blank for right now because there's something I'm going to use to help me to go back and fill this part in. So I'm going to go down to the last part that's given to me. It's going to form. So right here it says to form. That means this, all of this mixture over here is going to equal something. It's going to form 42 liters of a 55% solution. So now I know in total I'm going to have 42 liters. So that's kind of my little helper here. It's going to tell me that's the total I'm trying to get, 42. So what that means over here is if I have X amount of liters over here for my 67%, then I know over here the remaining part will be what goes with my 46%. So that means I'm going to take my 42 liters and subtract it from my X liters, and that would give me my remaining to go with this percentage, which is my 46. My total mixture here, of course, will be 42 liters of 55% solution. So remember, you're always multiplying your percentage times your liters. The amount of your solution, which is your liters, times the percentage. So now you have your equation set up, and from here you're just going to work the problem out. So the first thing I'm going to do is I'm just going to multiply, and on this side, remember, we're going to do distributive property. And when we do our distributive property, you got to remember that you're multiplying decimal numbers. So at this point, if you want to get your calculator and multiply all the way out, you can do that as well. We're going to get 19.32 minus 0.46x. And when we multiply 0.55 times 42, we get 23.1. Now, on this step here, we're going to add like terms. And when we add like terms on the left-hand side, we get 0.21x plus 19.32. And we're going to keep 23.1 there, because now we're solving this as a two-step equation, and we're dealing with decimals. So the next thing we're going to do is we're going to get all of our decimals to one side. So I'm going to leave my 0.21x on this side, and I'm going to move my 19.32 to the right side. So this was moved over, and remember, if it's positive on one side, it becomes negative or subtraction on the other side. Now I still have on this side 0.21x, and I'm going to move it over some now. And when I subtract 23.1 minus 19.32, that's going to give me 3.78. From here, and once again, if you're doing long division, of course, you'll move your decimal point over 2 places. Okay, so you're really doing 378 divided by 21. Using your calculator, you will just simply plug in and get your whole number of 18. So what this means is, the question says, how much of the 67% solution must she use? She must use 18 liters, okay, of the 67% solution. A motorboat can go 8 miles downstream on a river in 20 minutes. It takes 30 minutes for the motorboat to go upstream the same miles. Find the speed of the current. Now, this is the distance, rate, times problem. So I'm going to write down the formula: distance equals rate times time. Now, there are two things going on here. We're talking about a motorboat going upstream and downstream. So that means we're going to have two separate equations here. Let's look at the first one. A motorboat can go 8 miles downstream on a river in 20 minutes. Now, one thing we do know, since we have a motorboat that has speed also, with the current of the river also has speed. So we have two variables there to go with speed. I'm going to let my x, so I'm going to put an x right above motorboat. I'm going to let my x represent the speed for the motorboat. And I'm going to come here and put y in parentheses right above where it says current. That's the current of the river, so that's speed also. And I'm going to begin filling in my distance equals rate times time. Now, it says the motorboat can go 8 miles, so that's my distance. Downstream. Now, downstream, if you think about on a river, you're going downstream. That means you're going with the flow of the river. So that's going to cause the speed, your speed, to increase. So that means the rate here is going to be the speed of the motorboat plus the speed of the current. So I'm using y for the current. Our next thing is time. It says in 20 minutes. Now, when we're writing time here, we write it in terms of hours. So I'm going to come over here to the side and convert 20 minutes out of 60 minutes is 1/3 when you reduce it. So I'm going to write it in terms of 1/3 hour. I'm done with my first sentence. Let's go to the second sentence. It takes 30 minutes for the boat to go upstream the same 8 miles. So once again, the distance will still be the same. It takes 30 minutes this time, so we're going to write it in terms of minutes. So we're going to convert 30 out of 60 into 1/2. We now have 1/2 hour. And now we're going to talk about our speed, which is the rate. Now it says we are going upstream. So if we're going upstream, we're basically going against the flow of the river or the current. And so that's going to slow us up a little bit. So that means our speed will be decreasing. So we're going to use minus y because we're going upstream. Now, once you set up both your equations here, the first thing I look at is if I see a fraction in my problem, I want to see if I can eliminate that fraction because I like working with whole numbers better. So what I'm going to do is I'm going to multiply everything in this first equation by my denominator, which is 3. So I'm going to come here and multiply everything by 3 because I want to get rid of that denominator. And then I'm going to go to my second equation, and I want to multiply everything by 2 to get rid of my denominator. So once I do that, I'm going to form my new equations. And remember, this 3 has to be multiplied with every part, okay? 8 times 3 is 24. 1/3 times 3 cancels out. So I'm left with just x plus y. I'm done. Let's go to the second equation. 8 times 2 is 16. 1/2 times 2 cancels out, and I'm left with x minus y. Now my equation looks simple. I see that it is set up where I have my y's that are opposite each other, so that tells me I can use elimination. So I'm going to go ahead and use elimination by adding each of my columns. 24 plus 16 will give me 40. X plus x will give me 2x. And my y column will cancel out. When I divide by 2 here, I'm going to solve for x. And I get 20 for x. Now what that means is that's the motorboat, x. So that means the speed for the motorboat was 20 miles per hour. That's how fast the motorboat was going. But I must look at what they're asking me to find. It says find the speed of the current. So that means we need to find what y is. So I'm going to go back up to my first equation here, and I can replace my x with 20. So in other words, if I subtract 20 from my total speed of 24, that's going to give me 4, which would be the speed of the current. We're going to solve a system of linear inequalities by graphing. So we have our two inequalities, and the first thing we want to do in order to graph them, we must have them in slope-intercept form, which is y equals mx plus b. So if we look at the inequality in green, we see that it is set up in slope-intercept form. I am going to show the slope, okay, which is 1, so that I can see my rise over run. So I'm going to make it 1 over 1. Now, if I look at my inequality in red, I see that I need to subtract 2x on both sides. So when I subtract 2x on both sides, I end up with negative 2x minus 4. Now you want to keep it in slope-intercept form as well. Now I am ready to graph. So I'm going to start with my inequality in green. You always start with your intercept, which is on the y-axis. So I'm going to start at positive 4. And I'm going to put my dot here. Now the slope tells you how far you're going to go up and over, rise over run. So in this case, I'm going to go up 1 over 1 to the right from my beginning point. So from here, I'm going to go up 1 over 1 and put my second dot, up 1 over 1. And I'm just going to continue going up, but I also want to go down as well because I want to be able to see a complete line through the entire coordinate plane. So I'm just going to come down now, go down 1 over to the left. And you want to do about 5 or 6 going in each direction, but the goal is to try to cross over the coordinate plane, okay, because you want to be able to see a complete line. And once you get your line, then you can kind of get an idea of where your graph is going to, how it's going to meet up, where it's supposed to go. So now we have our green line, and I erased some of the dots. If you're using graph paper, which just have your lines, it'd be much easier. In this case, I'm just going by the board without the lines. So I'm going to go next, shading. Inequalities also include the dots that are on the line as well as there are dots that are off the line. So we have spaces outside that can also be included in this inequality. So it's not just one answer. We can have more than one. So what that means is I now have to look at my sign here, which is a less than sign, and that's telling me that all the dots that are less than, okay, that means fall below this line, are also included in the inequality. So I'm going to have to shade that entire area because it means all of those are included. Now when we shade, I'm using a marker, so I'm just going to kind of do a little, just some kind of design here so that I don't use all the marker, but shading below this line would be everything going this way. And I'm going to go ahead and extend my line out so you can kind of see it's still going to be everything going this way. All of these points here would be included when I'm shading below the line, okay? That's just to kind of give you an idea of what it should look like. It's everything there. So now I'm done with my first line. I'm going to go to my second inequality. My starting point is at -4 this time, so I'm going to go to my -4 on my y-axis, which is here. And this time, my fraction is -2/1, so that means I'm going to go down 2/1 to the right. So from here, down 2/1 to the right, down 2/1 to the right. And then, of course, I'm going to come up also, up 2/1 to the left, up 2/1 to the left, up 2/1, up 2/1, and then you kind of get an idea of where your line is going. Now, once again, you got to decide, is my line solid or dashed? In this case, there is a line underneath, which means equal to, so that means it must be solid because it must include all of those points as well. So I'm going to now make a solid line, and I'm going to go ahead and just extend it up so that you can see the whole line and that it covers all of your coordinate plane area. Now it says less than, so that means it must also include all of the points below it. Less than means below, greater than means above. So that means I'm going to have to also shade in all of the points that are below, or all this region. And just to kind of save time, I'm just going to quickly kind of just do some lines here so you can just kind of get an idea of what the shading would look like if you're coloring on your paper. In this case, I'm not going to color, so I'm going to just draw lines. But the key thing is for you to find the solution. And the solution is going to be where the colors mix here on the board. So you'll notice here, the colors are going to mix all in this area. You should see all in this area is where your colors mixing. So it should be all red over here. Then you have all green right here. But right in this area is where you should have your mixture of red and green. Or if you were using colored pencils, the color should be here. Or if you're just using a pencil, it should be shaded darker. So that means your solution is all of this. All of these points in this area will be your solution. So you will have many solutions here. Okay. On these two problems, we're going to solve the equations using any method that we like. So we've been taught quadratic formulas. We've been taught complete the square, factoring, difference of two squares. So you have several different methods you can use when you're trying to solve for the variable. What I'm going to do here is I'm going to solve using the square root method. So I'm going to add 6 to both sides. So when I solve this, I'm going to move my 6 to the other side. And then I'm going to divide both sides by 8. I'm going to be left with x squared is equal to 6/8. Now, when you're trying to solve for x, I must then take the square root of both sides. Now, at this point here, what you do on one side, you're going to do to the other side. And this is going to bring my x out. And this makes it plus negative always, because you can have a positive or a negative. Now, what I'm going to do here is, I see that inside of here, it can be reduced. So I'm going to go ahead and reduce it to 3 over 4. Now, at this point, I notice that my numerator will be a square root of 3, which cannot be simplified. I can leave my answer in this form, the square root of 3/4, which would be the plus or negative. Another way you can write it is plus negative the square root of 3 over the whole number 2, because you can take the square root of 4, okay, and get a whole number 2. So that's another way of writing it. Now, it all depends on what the directions say. If they want you to write it in a decimal form, then of course you could just go to your calculator, find the square root of 0.75, because 3/4 is 0.75. Find the square root of 0.75 and then write that in decimal form, which would be, in this case, plus or minus 0.87. Plus or minus 0.87. In the directions, they want you to round to the hundredths place. So that's what you would get here. All right, let's go over to number 7. Number 7, I noticed there are 3 terms here. So this is going to be a trinomial. So what I'm going to do is I'm going to move my 25 back over to the left-hand side. So I'm going to get minus 25 and set it equal to 0. Now, I'm going to use factoring because I see that I have a 1 as the coefficient. So I'm going to do factoring. So I'm going to look here at what multiplies to give me negative 25 and add to give me a positive 10. That's going to be, in this case, a negative 5 here. And we're going to see that, okay, if I try to do that, it's not going to work out for me. So when you get to this step and you say, okay, I want to do factoring, now it's easier. Once you get to this step and notice, well, I cannot find anything that will multiply to give me a negative 25, because it would have to be a positive and a negative number. And also that would give me a positive 10. That tells you then it can be factored another way. So we just can't say no solution anymore. So that means we're going to have to go the second route, which is completing the square, or if you want to do the quadratic formula, you can do that. So it all depends on what method you want to do. Always try to do your factoring first. Let that be your first method. If that does not work, then you know you got to try the other methods. So I'm going to put my 25 back on this side because it did not work over here. And I'm going to do completing the square. So remember, completing the square means you're going to take half of b and square it and add it to both sides. So we're going to complete those 4 things. Those are your steps. So half of b would be 10 over 2, which is 5. And when I square 5, I get 25. So I'm adding 25 to both sides. Half of b and square it. Add it to both sides. Now this becomes a perfect trinomial. I can now factor this now because there's a positive 25. Remember, it would not work with that minus 25. So now I know 2 numbers that will multiply to give me a positive 25 and add to give me a positive 10 would be x plus 5. Now I'm going to write it out so you can kind of see exactly what it looks like. But now what I'm going to do is I'm going to go ahead and just bring it back together and just write it one time using the square. And we're going to work this problem out just like we did over here. Since we have the square, I can get rid of the square by taking the square root. So I'm going to do the same thing over here. Get rid of the square by taking the square root. What you do on one side, you want to do it on the other side. So now I have x plus 5. And remember, this becomes plus negative the square root of 50. Now I'm going to move 5 over to the right-hand side because I'm trying to solve for x. When I move 5 over, it becomes a minus 5, and I'm going to put it in front. It doesn't matter if you put it in front or behind. And I'm also going to just simplify down because in all of our problems, we want to simplify them all the way down to lowest terms. So in radical form, I know I can get a perfect square out of this one because 25 times 2. And I know 25 would give me a whole number of 5. And I can have my 2 left under the radical. Now at this point, this is your answer in simplified form. Once again, if it asks you for the decimal answer or if it's asking you to round to a certain decimal place, that's what you want to do. You want to put that into your calculator. And now we want to simplify each radical expression here. So when we think about radical expressions, the first thing we want to think about are perfect squares. Can we get a perfect square out of the number underneath the radical? So when I look at this problem 160, I see 16 automatically because I know 16 times 10 will give me 160. And I know that if I break this up, the key thing you want to do is show your perfect square. So always be thinking about a perfect square. How can I get a perfect square out of the numbers that I have underneath my radical? Now, when I break it up in 16 and 10, I notice that the square root of 16 is a whole number 4, so I'm multiplying by 4 now. The square root of 10, if I break that up, I'm going to get 2 times 5, and neither one of those numbers are perfect squares, so I'm going to just leave it in that form, leave the 10 there. Now I can simplify. Negative 4 times 4 is negative 16. Square root of 10. You also have your coefficient in front of the radical, just like we do with variables. Always have your number in front. And this is now simplified. Let's look at number 9. Once again, you want to think about perfect squares. So I know 9 times 8 will give me 72. I know 9 is a perfect square. Now what you want to do here is just simply take the square root of 9 and get 3. Now when I break up 8, I see I have another perfect square. So sometimes you may have to go more than one time. Or you may find another perfect square at the very beginning. That's different. And I'll show you another way in just a minute how it depends on your steps. So now I see I have negative 3, the square root of 4 is 2, and then of course the square root of 2. Now I'm going to simplify this like I did over here and get negative 6, square root of 2. Now, I could have used the square root of 36 with the square root of 2. Because 36 times 2 gives me 72. And 36 is also a perfect square. So the square root of 36 is 6. And look, I only used 2 lines here. Okay? So once again, if you can't think of a perfect square, the highest perfect square to begin with is okay. You're just going to have more steps. But at the very end, you should still get the same answer. Here we're going to simplify the expression. This time it is addition. So we're going to treat this radical expression just like we would treat a variable. We're adding like terms. So we want to make sure our radicals are the same in order to add them. Now, when I look at the first term here, my 7 cannot be simplified, so I'm going to leave it alone. It's already in its lowest terms. But when I look at my 63, I know I can break that up into 9 and 7. And this 7 here kind of helps me out to see if I can get a 7 out of 63. Because then I know I'm probably going to end up getting a like term. So that's what you can look at as well. Now when I continue to simplify this down, I'm going to have 8 times 3, because the square root of 9 is 3, times the square root of 7. 8 times 3 is 24. At this point, I notice that my radicals, the number under my radicals, are identical. So now we have like terms. Whenever you're adding radical expressions that are the same, you must only add their coefficients. So we're going to add 4 plus 24, which is 28. And of course, The number underneath your radical cannot be added together. It is the term, so you must keep it the same. You can't do anything to it. It's just like a variable. So you're going to treat it like one. So our final answer here is 28 square root of 7. Number 10 here, negative 5.4 to the 0 power. We're going to simplify this. And anything to the 0 power is just 1, okay? So that was very simple. Anything to the 0 power, any number, any rational number, any whole number to the 0 power is always 1. Now we're going to simplify this expression here. Notice we have g to the negative 11 times h to the 4th over g to the negative 20th times h to the 14th. So we have two variables with g, two variables with h, and we're going to simplify it down so that we only have one of each variable. Now there are rules, exponent rules. Whenever you're doing division, the rule is to subtract the exponent in your numerator from the exponent in your denominator. Or, in other words, the numerator minus your denominator. That's what you want to do. So we're going to rewrite this so that you'll understand what we're doing. Basically what I'm doing is I'm going to move everything to my numerator because then it's easier for me to add. So the rules for subtracting, if I move my g to the negative 20th up to the numerator, it becomes g to the positive 20th. I'm going to bring my h to the 4th back. I'm going to move my h to the positive 14 up to my numerator. So now I have h to the negative 14. Now, once you move everything up to the numerator, remember you are multiplying all of them now. Sometimes you can get confused if you want to subtract, but it's easier if you have them in multiplication form so that you can just add your exponents. It makes it easier. So now on my g, if I add my exponents here, I have a negative 11 and a positive 20. That's going to give me a positive 9 when I add those together. Here, if I add 4 and negative 14 on my h, that's going to give me a negative 10. So now I have my final answer as g to the 9th, h to the negative 10th. Now, it all depends on what the directions say. Sometimes your directions may tell you to make sure your exponents are always positive. So in this case, if I had to write them so that my exponents are always positive, I would move my h to the 10th to the denominator so that it becomes a positive exponent. So either one of these would be fine, but double check in your directions how they want you to write your final answer. Now, if it does not say, then you have the choice of how you want to write it. Now, let's just look back at this one. What if I did not want to move everything up to my numerator and add? What if I just wanted to subtract? Then what I would do here, I'm coming over here now, I would do g to the negative 11 minus negative 20, okay? Because I'm doing my top exponent minus my bottom exponent. And then on my h, I would do 4 minus 14. And now when I simplify, remember 2 negatives turn into 2 positives. So I really have negative 11 plus 20 is 9. And 4 minus 14 is negative 10, which is what I got here. So you have the choice of how you want to write your final answer. You have the choice of whether you want to do multiplication first or division. And you have a choice of you want to add or subtract. But your final answer, of course, either way. All right, let's look at the next problem. We're going to solve now, and we're solving for w. So I noticed in this problem that I have a square root symbol. So in order to get rid of that square root symbol, I'm going to have to do my inverse, which is to square both sides, because I need to remove that 7w from under the radical. So I'm going to square both sides. And when I square both sides, you want to show what you're doing. So I'm going to show that on both sides I'm squaring. On the left side, w squared is simply w squared. On the right-hand side, 7w now comes from underneath the radical because the square root and the square cancels out. Now we want to solve for w, but I noticed we have w squared on one side and w on the other side. So what we're going to have to do is move them all to one side and set the equation equal to 0. Once I get into this form, I notice I have a binomial. So when I have a binomial, I want to look to see if there's anything common that can be taken out. So I'm going to factor out the greatest common factor. And in this case, w is common in both terms. So when I factor out w, I'm left with w minus 7 inside of my parentheses. Now I have two separate terms here that I'm going to set equal to 0. So w will be set equal to 0. W minus 7 will be set equal to 0. So then, of course, my answer will be w is equal to 0, or w will be equal to 7 because 7 minus 7 will give me 0. So these would be your two answers, 0 or 7. Now remember we say or because it can only be one of those at a time. You can't have it for both at the same time. So this is why we use or to show that we have two answers here. For this problem, we want to multiply the rational expression. The first thing we want to do is we're going to notice that there is no factoring that needs to be done. So the only thing that we can do here is start canceling. You can cancel numerator with denominator, but you cannot cancel numerator with numerator or denominator with denominator. So I'm going to look and see that 2 in my denominator can go into 2 one time. 2 can go into 4 2 times. And when I look, I want to see if there's anything else that can be canceled. In this case, if there's nothing else that can be canceled, now we're going to just multiply the fraction, numerator times numerator, denominator times denominator. 2 times 3 is 6. Denominator, 5 times 1 is 5. And I have variables that are the same. So when you're multiplying variables that are the same, you add their exponents. So I'm going to put a little 1 here on this a so that you can see it. Sometimes if you don't show that 1, you will forget to add it. You'll think of it as a 0. So now I'm going to add 1 plus 2, and that gives me a to the 3rd power. And this is your final answer. There's nothing else you can do to this problem. You're done. Let's look at the next problem. We want to solve, and I see I have radicals. So the first thing we're going to do here is we must get rid of the radical. And we already know the rule. In order to get rid of a radical, you must square it. So I'm going to square both sides. So once again, I'm just going to show it up here. I'm squaring both sides, putting them in parentheses. Once I square both sides, the expression underneath the radical comes out. Now I want to solve for x, and I notice this time that I have an x on both sides of the equation. So I must move all of my x's to one side and move all of my numbers to the other side. So I'm going to switch positions with these two. So when I move 6x to this side, it becomes minus 6x. And when I move minus 6 to this side, it becomes a positive 6. Now I have all of my terms on the correct side. 5x minus 6x gives me a negative 1x. 6 minus 9 gives me a negative 3. So, of course, negative 1 times 3 would give me negative 3. So you have solved for your variable x which is 3. For this problem, we're going to solve the rational expression, and we notice here we have fractions this time. And remember the rule about fractions. When you're adding fractions, you want to make sure your denominators are the same. So when I look at this problem here, I notice that they both have x's, so my denominators are the same. Whenever your denominators are the same, then you can add your numerators. So 2 plus 4 would give me 6 in my numerator. My denominators, you cannot add them together. That just becomes your common denominator. So you're going to write the x one time here. And we're going to set it equal to 1, which is on the right-hand side. Our next step is to solve for x. We have to get x on the side by itself. And right now, my x is in my denominator. So I want to make sure my x is in my numerator in order to solve for it. So I'm going to multiply both sides by x. Some people will multiply both sides by x, which is the same thing as saying cross multiplying. Okay, so you can do it either way. When I multiply this side by x, I'm left with 6. 1 times x is x, and I was able to solve for my variable x, which is 6. All right, let's look at the next problem. A yogurt shop offers 3 different flavors of frozen yogurt and 8 toppings. How many choices are possible for a single serving of frozen yogurt with 1 topping? So we're going to say if we have 1 flavor, for example, chocolate, then I have 8 choices to choose from for my toppings. Or I may want to get strawberry, and I have another 8. Or I may want to get vanilla, and I have another 8. And even though they're all the same, but you have those different choices that you can get. Now, there are several ways you can do this with mapping. Okay, I can have choice number 1, choice number 2, and choice number 3 for my flavors. These are my flavors. And for each one of those, it's going to give me my 8 toppings. And if I repeat that process here, it's going to give me my 8 toppings and my 8 toppings. Now, this is a lot of work to draw it out, to do the diagram. But if you don't understand what your outcomes are going to look like, it is best to write them all the way out. Now, the easiest way, if we're just trying to find the total number, okay, of choices we have, we're just going to multiply the number of flavors. How many outcomes we have for our flavors? 3. How many outcomes we have for our toppings? 8. And when we multiply that, that's going to give us 24, which is our total number of possible choices. If you were asked to list them all, then of course, making a mapping will be the best way to go to actually show the list of all your possible choices. So the answer for this problem is 24 choices are possible. So in this problem, we have a right triangle, and we are asked to find the missing side, in this case, C. Since this is a right triangle, we will be using the Pythagorean theorem to help us solve for C. And the Pythagorean theorem is a squared plus b squared equals c squared. C is always your hypotenuse, and A and B are your legs of the right triangle. So what I'm going to do first is just simply replace my variables here with my numbers. So 7 squared plus 12 squared is equal to c squared. And we're going to leave the variable c because we're trying to solve for c. 7 squared, when we simplify, is 49. 12 squared is 144. And that is still equal to c squared. When I add 49 to 144, I get 193, which is equal to c squared. Now, I still need to solve for c, so that means I need to get rid of that c squared. And if you remember the rule, in order to cancel out a square, we must use its inverse, which is the square root. So I'm going to do square root on the left side, square root on the right side. That's going to allow my C to come down. Now, normally with any square root, when you take the square root of that number, you get two answers plus negative. But since this is a shape and these are measurements, measurements are never negative. So that means we will not put plus negative here. Our answer will simply be the square root of 193. Now I'm going to leave it in this form because I can't simplify it down anymore. But if I was asked to write it in a decimal form, I would simply just go to my calculator and get the decimal form of it and round it to the place it was asked. But for right now, I'm just going to leave it as the square root of 193. All right, let's look at the next one. This is a radical expression with fraction form. So remember on this problem here, we can simplify numerator and denominator. Sometimes you can simplify numerator without simplifying the denominator. Now, in that case, you want to always make sure your denominator can be simplified. You never want to have a radical in your denominator. So we want to look to see, first of all, we have perfect squares. You can break it apart like this if you want to, or you can leave it as one fraction. It means the same thing. So I'm going to take the square root of 64 and get 8 for my numerator, the square root of 25 and get 5 for my denominator. I'm going to leave it in an improper fraction form unless the directions say write it as a decimal or write it as a mixed number. But in this case, it has been simplified down. This is my final answer. So in this problem, we're trying to solve the rational expression. And we notice that we have an x squared in here, so it is quadratic. I'm going to, since I cannot find anything common out of my binomial, I'm going to move my 20 to the right-hand side because I'm going to find the roots of this. When I move my 20 to the right-hand side, it becomes a minus 20. So I end up with x squared is equal to negative 16. Now, I can stop here because I see that x squared is going to equal to a negative number. It can never equal a negative number. It must always equal a positive number because you're squaring it. So you can stop here. If you just forget that part and say, okay, I'm going to take the square root of both sides because I am trying to solve for x. I'm not trying to solve for x squared. So I'm going to take the square root of both sides. That gives me x is equal to the square root of a negative 16. And we know here that you can never have a negative under a radical. So at this point here, I see that there's a negative under the radical. So I know there is no solution for this problem. No solution. All right, let's look at the next problem. This is a right triangle, and we're trying to solve for x. If we notice here, this is an isosceles triangle, and I need to find what each side is. I also see that the area is equal to 24. So now I know I'm dealing with the area of a right triangle. That means I'm going to use my formula for the area of a triangle, which is 1/2 the base times the height. And what I'm going to do first is just start plugging in what is given to me. So in place of the A here, I'm going to use 24 because that's my area. In place of the base, x, and the height, x. So I'm replacing now. I'm going to simplify. X times x gives me x squared. Now I'm trying to solve for x, so I must get rid of my 1/2. And remember, to get rid of 1/2, that's the same thing as multiplying by 2. So if I multiply by 2 on this side, I must multiply by 2 on the left side. So I end up with 48 is equal to x squared. Now, I'm going to take the square root of both sides again because I'm trying to solve for x. The square root of 48, square root of x squared. So I end up with the square root of 48, which I'm going to break down into the square root of 6 and the square root of 3 because I know I can get a perfect square out of this. 16 times 3 is 48. Now, the square root of 16 is 4. And remember, we're talking about the measurement of the side of the triangle, so we can't use negatives at all. So our final answer here in simplified radical form is 4 square root of 3. Now, if it asks you to write it in a decimal, then of course you would have to use your calculator to find the decimal and round it to the correct place. So here we have 4 square root of 3. For this problem, we're going to write the expression in simplified form. And when we're writing an expression in simplified form, we look at the exponent of each term, and we put it in order from from greatest to least. And of course, our constant term will always be last. So 10g, there is a 1 as an exponent, so you want to show that sometimes so you don't think it is a 0. Now I'm going to put my 3 is the largest, so I'm going to go from greatest to least on my exponents. And notice that minus sign, that is with the 7, you must keep it in front of the 7. So even though it is a minus sign, it is still representing the 7 as a negative number. So we have negative 7g to the third plus 2g squared plus 10g to the first minus 3. Now remember, if there's no sign in front of your first term, it is understood to be positive. So we have simplified this expression. Negative 7g to the third plus 2g squared plus 10g to the first minus 3. Now we're going to look at the next problem. This one is simplifying, and this is a subtraction problem. We're going to find the difference. Now, one thing we must remember, when you have terms in parentheses, the sign on the outside of that parentheses is going to be distributed with each term on the inside. So what I mean by this is we're putting this minus to every term. So it's kind of like a negative 1 here. We're multiplying with every term. So I'm going to rewrite my first expression. And then I'm going to do distributive property with my negative 1. That becomes a minus 7w squared minus 4w plus 4. Now we have gotten rid of our parentheses. Our next step is to add like terms. And once again, when we're adding like terms, we want to always look at our variable. And the variables, they have the same exponents. They're like terms. So I'm going to just kind of put a line underneath my w squared group. I'm going to put 2 lines underneath my w group. And then I can leave my constant group just without a line, okay? What I'm doing here is just identifying all of my groups. Now, I want to keep it in standard form, so I want to keep my highest exponent first. So I'm going to go with 2 minus 7 is going to be negative 5w squared. Then I'm going to go with my w group. Remember, I have a negative 8 and a negative 4. That's negative 12w. Or you can say minus 12w. It means the same thing. And then I'm going to go with my constant group. I have a negative 7 and a positive 4. That is negative 3 or minus 3. So at this point, there are no terms that are the same. We have simplified it down to its lowest. And they are in standard form, so our answer is done. With this problem, we're going to simplify the product by doing distributive property again. So I'm going to just draw my arrows now. And the reason why I want to draw my arrows is this is just going to keep me from forgetting to do one of my terms. Now remember, when we are multiplying exponents, okay, on variables, you must add them. So the rule is when you have to multiply and you have variables, you simply add their exponents. So we multiply numbers with numbers and we add the exponents on our variables. So we're going to multiply 2 times 1, which is really just 2 here, because that's a 1. And then our variable, remember this n has that 1 as an exponent, so I'm going to write it in there so I don't mistake it as being a 0. So 1 plus 2 gives me 3, so I have n to the third power. I'm going to bring down the plus sign. Number times number, 2 times 3 is 6. I'm going to add my exponents. I have a 1 here, and this is a 1 also, which makes that n to the second power. And then I'm going to multiply my third term. 2 times 4 is 8, and the n to the first power comes back down. Once you have multiplied by doing distributive property, you then want to look to see if there are any like terms in your expression that can be combined. In this case, there are no like terms, so we are finished with this problem. This is our final answer. Let's look at 24. We're going to simplify this product also. We are multiplying, and we're multiplying 2 binomials. Now, what you want to do when you're multiplying binomials, you want to look to see if there are some things, if you see a pattern or some things that are going to make it easier for you. Now, normally what we do when we multiply 2 binomials is we do the FOIL method, first, outer, inner, last. But I also see that both of these have the same terms, they're just opposite signs. And they're really difference of 2 squares. So you can just multiply the outside, which is the first, and then the last. If you multiply the first and the last, your outside and your inside, they already are opposite each other. So these 2 signs kind of represent your O and your I, okay? So we got our outer and our inner, they really cancel out because they're opposites. That's the point when you have it this way. So here I'm just going to multiply 5 times 5 to give me 25, and p times p gives me p squared. Now, since I'm multiplying a negative times a positive, I know my sign in the middle will be negative or minus. And then I'm just going to multiply 6 times 6 is 36. Now, this only works when the terms are identical to each other and the signs are opposite. Now, I am going to show you, if you just can't remember this, just do normal FOIL method and you'll see it still comes out to be the same. So I'm going to do first, which is first 5p times 5p, which is 25p squared. Outer would be the 2 outside terms. 5p times a positive 6 is a positive 30p. Inside would be the 2 inside terms, which is negative 6 and 5p, which is a minus 30p. And then last would be my minus 6 and my plus 6, which would be minus 36. So if you did your FOIL method, this is what it will look like. And again, we're going to add like terms. In this case, remember they're opposites of each other, so they cancel out. And your final answer is 25p squared minus 36. And of course, if you want to check your answer, you can go back and do difference of 2 squares and factor this, and this will be your final answer. Now we want to factor these 2 expressions. The first one, notice when we're factoring, we want to see if we can keep a 1 in front of our x squared. It makes it easier to factor. And in this case, we have a 1 here. So now we want to find out a times c, which is negative 42. So we're going to find 2 numbers that will multiply to give us negative 42 and add to give us a negative 1. So remember, there is a 1 in front of that x. 2 numbers that will multiply to give us negative 42. So if I list my factors here, I get negative 7, positive 6. I can also get a positive 7 and a negative 6. You can also get, let's see, 2 and negative 21, negative 2, positive 21, 1 and negative 42, negative 1 and positive 42, There's 3 and 14. So there are a lot of numbers here, okay? A lot of factors that you can get that's going to give you this negative 42. So we can get a lot of factors. Now the key thing to make this go easily is to try to think of what it's going to be adding to always. So you want to think about what will it be adding, because if I just look and say, okay, 2 and negative 21, I know it's not going to give me negative 1. So we know those will cancel out. When I add these two, I cannot get negative 1. The same for these two factors. So I know negative 1 is going to be here. There's a difference of 1 between 7 and 6. So that kind of helps you out. Now we must determine one of those numbers must be the negative because of that sign. So you're going to always look for the highest number. The number that's the highest must be negative according to the sign rule. So in that case, it would have to be the negative 7 and the positive 6. So I'm going to put those in each parentheses. X and X automatically goes as our first term because that makes x squared. Now we're going to put minus 7 and positive 6 in each parentheses as well. And those become our last. Now if you want to double check this to make sure it checks out, you go back and do the FOR method. And when you do the FOR method here, x squared, positive 6x minus 7x minus 42 would give you this answer. And that kind of tells you that you have done it correctly. Now, we have just factored this. There are no other common terms that we can take out, so we're done with this problem. Number 26, we want to factor also, but we have 4 terms here. Now, normally when you see 4 terms, you want to think about grouping. There are several ways you can do this problem. One way is to see if you can get a 1 in front of your x squared group. And in this case, we have more than 2 terms. So 4 terms, I'm just going to do grouping, okay? So I'm going to factor these 2 and factor those. When I look at just these 2, I see I can take out a 3 because I'm going to take out what's common in each term. That means number and variable. So I can take a 3. I can also take out x to the 3rd because that is the smallest, and it can go into both. In my parentheses, I'm going to put what's left over. So I'm going to divide with my numbers and subtract with my exponents. So 6 divided by 3 gives me 2, and x is to the 1st power. Same thing for my second term. There's my minus sign. 3 will go into 9 3 times, and the x to the 3rd cancels out. So I have factored my first term. Now I'm going to go to my second group, and I'm going to take out what's common here. Now I notice there is an x that can come out. I also see 36 and 54. Now when you're doing this, you're going to notice, well, I can take a 9 out. But then you want to think about, is that going to be my greatest common factor when I take out? So then I think, okay, can something else go in higher? And in this case, 18 can go into both. So I'm going to take out 18 here. And notice when I put a minus sign here and put my 18 and the x, notice what happens on the inside. If I take out my minus, that's going to turn this into a positive, okay? Because I'm taking that negative away. So that now becomes a 2 because negative 36 into negative 18, going divided by negative 18 gives you a 2 here, and it is positive. And then, of course, the x. When I take a negative away from a positive, because remember a positive is really 2 negatives, so when I take a negative away from that, it leaves the other negative on the inside with it. And then, of course, 18 times 3 gives us 54. So the key thing when you're grouping is you want to make sure your terms and your parentheses, they must be identical to each other. So if you start seeing they're not identical to each other and maybe one is opposite, that means you just need to take out your negative. Or if it's opposite and the negative is on the outside, then you need to add the negative back on the inside and turn this into positive. So it all depends. You just have to look at your parentheses. Now that I see that both parentheses are the same, I'm factoring that parentheses out. So that is my parentheses that has been factored out. And what's left over would be my terms in front, which are the coefficients. So I have 3x to the third minus 18x. Now we want to factor this completely. Even though I have factored it down, I still need to look to see if I can factor some more, okay? And this parentheses is already factored down to lowest terms, but I noticed there's a 3 that can come out, and there's an x that can come out. So I'm going to rewrite my 3x to the third, 3x minus 3, and I'm going to factor out a 3 with an x, and I'm going to put all of my coefficients in front. So my 3x comes to the front, and I'm going to put what's left over here, which is going to be my x squared minus 6. At this point, you want to look again one more time, because sometimes you can, if you don't use your greatest common factor, you'll end up factoring until you get to the lowest. So it's okay if you don't necessarily know the greatest common factor to begin with. Just know you're going to have more steps along the way. So at this point, I want to look to see if I have anything else that can be factored out. And in this case, there's nothing else that's common, so this is my final answer. Okay, in this problem, we're going to solve this system of equations. We must solve for x and y this time. And we're going to use the elimination method because, number one, we already have them in standard form, which is your ax plus by equals c, and it's easier to use the elimination method. Now, the one thing we have to do in order to eliminate one of the variables, they must be opposites of each other and also have the same terms. So if we look at both of these, we see there are two ways we can do this. We can either multiply with this x in order to get them to be the same, multiply everything by 2. Or if we want to cancel out our y's here, we can either multiply this one by a negative 2 to end up canceling. So you have the choice. And what I'm going to do on this problem here is I'm going to take my first equation and multiply it by negative 2. So when I multiply by negative 2, I'm going to drop down here and make my new equation now. I'm going to do this derivative property and get negative 2x minus 4y equals a positive 2. Now I can add each column. When I add my x column, negative 2 plus negative 2 is a negative 4x. Notice the y column now cancels out, and 2 plus 2 is 4. Now I can solve for x divided by negative 4. So for x, we get negative 1. Now, in order for me to solve for my y, I can choose either one of the original equations and just plug my x back in place. So I'm going to take this original equation here, and in place of my x, I'm going to put negative 1 plus 2y equals negative 1. So I'm using the first equation. I'm going to add 1 to both sides. So when I add that negative 1 to both sides, it becomes positive on the right-hand side. So now I have 2y is equal to 0. And of course, y is going to be equal to 0. So your final answer, I'm just going to write it as an ordered pair, negative 1 for my x, 0 for my y. Now, once again, once you get your x and your y and you want to check this, plug them back into the equations here. So if I have negative 1 plus 0, because 2 times 0 is 0, that will give me negative 1, and it checks out. And you can also check it in your second equation as well. So the solution here is negative 1, 0. Let's look at this problem. The sum of two numbers is 82. Their difference is 30. Write a system of equations that describes the situation. Solve to find the numbers. Now, we're going to set up two equations here. So we're going to take our first sentence, the sum of two numbers is 82. So I'm going to use x and y as my variables. Sum means addition, is means equal, and I have my 82. Their difference means subtraction. So my second equation, x minus y, is 30. Now I have its standard form. I also see that my y's are opposite each other and they have the same terms, so I know I can use elimination to solve. So I'm going to add each column again. X and x is 2x when you add them. My y column cancels out. And when I add 82 and 30, I get 112. I'm going to divide both sides by 2. And I end up with 56 for my x. Now, I need to know what my y is. So once again, you have the choice. You can choose either one of these to plug your x in, okay? So if I choose my top equation, that means I'm going to take my 82 here and subtract my 56 in order to find my y. So I'm going to come over here to the side and do subtraction. And I see that 26 would have to be my y because when I add 26 and 56, that gives me 82. So that means y is equal to 26. And once again, if I plug it into this equation, 56 minus 26 will give me 30. So now you see your solution in this problem is 56 for x, 26 for y. In this problem, we are going to evaluate the expression 7x to the negative 2 power times y to the second power, for x is equal to 2 and y is equal to 3. Now the first thing I'm going to do on this problem, I notice I have a negative exponent, and you cannot solve an expression that has a negative exponent when you're trying to take a number to that exponent. So the first thing I'm going to do is I'm going to keep my y to the second with my 7 in the numerator because it has a positive exponent. But my x to the negative 2, I'm going to bring it to my denominator and make it a positive exponent. That's the rule that you would do. Now that I see that my exponents are now all positive, I can now evaluate by inserting my numbers in place for the variables. So in place of x and y, I'm going to use 2 and 3. So I have 7. Y is now 3 to the second power. X is 2. So I have 2 to the second power. Once I have substituted, now I'm just going to simplify. 3 squared, this is like order of operations now. You can't multiply first. You must do the squaring first, which is the exponent. 3 squared is 9. So I have 7 times 9 over 4. 7 times 9 is 63. 63 over 4 would be your final answer. In this case, if they want you to write it as a mixed number, of course you can. It is simplified. It can't be reduced to lowest terms, so you're now finished with this problem. Let's look at the next problem. We're going to solve. This is a proportion, two fractions that are set equal to each other. So in order to solve proportions, you must cross multiply and then divide. So I'm going to cross multiply 4 times w plus 14 and set that equal to 3 times 4w plus 6. Now, because those were binomials, I must set this up into distributive property form when you're multiplying. I'm going to simplify by doing distributive property. 4 times w is 4w. 4 times 14 is 56. On the right, 3 times 4w is 12w. And 3 times 6 is 18. I notice I have w's on both sides of my equation, so I want to move all of my variables to one side and move all of my numbers to the other side. So I'm going to switch these two. So I get 4w minus 12w. and I get negative 56 plus 18. Now, sign rules, 4 minus 12 is negative 8. And on this side, we have a negative 56 and a positive 18. And remember, you are subtracting basically. So we know 38, when I subtract, and also since my highest number is negative, I have to put that negative sign on the number. Next thing, I'm trying to solve for W, so I'm going to divide both sides by the negative 8. And remember, if that number is negative, you must put that negative on both sides when you're dividing. 2 negatives will cancel out to make a positive number. And I also see that I have even numbers, so I know I can reduce that. So it can be simplified if I divide by 2. So 19 over 4 will be your final answer in reduced form. So in this problem, we have a graph, and we want to write the slope-intercept form of this line. So the first thing we need to do is we need to know the formula for slope-intercept form. Y equals mx plus b. Now, your y and your x are your variables. They stay the same. You won't change them. So we will be replacing the m and the b. Now, your b is your y-intercept. That's the point that touches the y-axis. And your m is the slope. That's your direction, rise over run of your line. So the first thing I'm going to do is I'm just going to write the y back down. And I'm going to write my x back down. And the first thing I'm going to do is look for my y-intercept where the line is crossing the y-axis, and it's crossing at negative 1. So negative 1 or minus 1 would be for the y-intercept. Now let's look at my slope. Remember, your slope is how far you're going up and over or down and over to the left. So I'm going to start at my starting point, which is negative 1, and I'm going to count how far will it take me to go up and over to the right to get to this point. So I'm going to go up 1, 2, 3, and over 1, 2, 3, 4. So I see 3 over 4. Now, you can also test it again just to make sure it is correct, because sometimes it may work one time for one point, but it may not work for all of them. So you want to just make sure it does work for all of your points. And you will see that yours will be on a grid, and you can kind of see where they meet at corners. So they should meet at corners where your lines touch. But on the board here, the lines aren't there, so you just have to count it. So I'm going to go back to my starting point. This time I'm going to go down 1, 2, 3, and go over 1, 2, 3, 4. And I see if I went down and to the left, I would still get negative 3 over negative 4, which is the same as this slope. So this would be the slope of your line, y equals 3/4 x minus 1. The next problem, we have 2 equations here, and we must determine if they are parallel, perpendicular, or neither. So the first thing you want to do is you want to make sure both of them are set equal to y, so you want to get them in slope-intercept form. Now, the first equation is set up in slope-intercept form, so I'm going to now just work on my second equation. So the first thing I'm going to do is move my minus x. I'm going to move it to the right-hand side. So I'm going to rewrite the negative 4y. I'm going to bring it down. And when I move my minus x to the right-hand side, it becomes a positive x. And I'm going to put that positive x in front of the minus 5 because I want to keep it in slope-intercept form. Now, also, I noticed there's a blank there, so I'm going to put a 1 again so that I can see my fraction when it's formed. I have negative 4y, but I'm trying to solve for y, so that means I must divide all the parts by negative 4. All 3 terms by that number. And now when I simplify this, now I have negative 1/4 x, and 2 negatives here on this fraction make a positive 5 once you get both of your equations in slope-intercept form, in order to determine if those lines are parallel, perpendicular, or neither, we now look at the slopes. So when I look at my slopes here, I see negative 1/4 x here, so my slope is negative 1/4. I see negative 1/4 x here, so my slope is negative 1/4. And if the slopes are the same, that means those lines are parallel. So yes, these lines are parallel to each other because their slopes are the same. So in this problem, once again, we want to determine if these two lines, when they're graphed, will they be parallel, perpendicular, or neither. So once again, we must get both lines in slope-intercept form. Notice the first line is set up in slope-intercept form, so I'm going to rearrange my second equation here. So negative 4y, again, is on this side. I'm going to move 6x, and it becomes minus 6x on the other side. I'm going to divide all three parts again by negative 4. And when I simplify, I get 6 over 4x, because the two negatives cancel out and make a positive. Two negatives here, so that becomes plus, and if you want to go ahead and reduce that, you can, to 9 over 2. Now, I'm going to look to see if my expressions here, if the slopes are the same in the expressions. When I look, I see they're not the same. I also see that they have two different numbers, which kind of tells me that I probably need to simplify the slope here. So I can simplify the slope and get 3 over 2x. Now I notice that the numbers are the same, except the slope here is negative 2 over 3, and the slope here is 3 over 2. So they're not the same, which means they're not going to be parallel lines, but they are opposite each other, and they are reciprocals. So whenever you have slopes that are opposite reciprocals, they are then perpendicular to each other. So the lines in this problem here would be perpendicular. A yogurt shop offers 5 different flavors of frozen yogurt and 9 different toppings. How many choices are possible for a single serving of frozen yogurt with 1 topping? So we're simply going to multiply the different flavors, which are 5, times the different toppings, which are 9. And we get 45. So the answer would be 45 choices are possible for a single serving of frozen yogurt. For this problem, we will be dividing polynomials. And we notice here, these are fractions. And we also notice that within those fractions, we can do some factoring. So what I'm going to do with my first fraction, okay, is I'm going to take my numerator and factor it. So I'm going to see what multiplies to give me 20 and adds to give me 9. Those two numbers will be 4 and 5. So I'm going to have x plus 4 in my first parentheses and x plus 5 in my second parentheses. My denominator in my first fraction is a binomial, and it has a minus sign, and I have perfect squares. So this is a difference of 2 squares, so I can factor that. X times x gives me x squared. 5 times 5 gives me 25. And since my 2 middle terms are canceled, there is no trinomial here, the middle term is missing. That means that these must be opposite each other as far as the sign. So you have one with the minus sign, the other one with your plus sign. So now I have factored my numerator and denominator for my first fraction. Whenever you have division, you must change division to multiplication in order to solve. So we're going to change division to multiplication, and I'm going to use a dot instead of the x because I have x's here already, and I don't want it to be confusing. So I'm going to put a dot for multiplication, and whenever you change your division to multiplication, it's kind of like you're doing the reversal. So we have to reverse our fraction or take the reciprocal. So that means x minus 4 is in my numerator, and x plus 4 is in my denominator. At this point, once you've gotten everything factored, now you want to start canceling. So I notice here x plus 4 will cancel with x plus 4. X plus 5 will cancel with x plus 5. And in my numerator, I'm left with x minus 4. In my denominator, I'm left with x minus 5. There's nothing else that can be canceled because there's no multiplication going on. These are two binomials that are separated by a minus sign, so you cannot break them up. So your final answer is x minus 4 over x minus 5. Number 36. How many different arrangements can be made with the letters in the word power? Now, in this problem, we're talking about arrangements, and we're talking about where the order of these letters will make a difference. In other words, you can't go back and do any repeating. So when we talk about this, we're talking about permutation. And what we want to do is we want to first start and say, okay, so with power, there are 5 letters. So I can get arrangements with power, P-O-W-E-R, or we can do O-W-E-R with the P at the end. So you can do several different arrangements there, but you can never repeat. And then I can take off a letter. So I can say, what if I want to just make the arrangements with only 4 of the letters? So in this case, you don't have to use all of the letters. So if I want to use only 4 of the letters, or I can use 3 of the letters, 2 of the letters, or just use 1 letter because those are all different arrangements. Those are the different arrangements. So this time we will have to use permutation, which means you simply multiply by all the different outcomes that can happen before the arrangement. So that means we're using 5 letters to begin with. And out of those 5 letters, we can have several different arrangements out of those 5 letters. We can take 1 away and have 4 letters. And then, of course, you can find the combinations with 4. The same with 3, 2, and 1. So with permutation, you simply multiply each one. And we call this factorial as well. So when we multiply 5 times 4 times 3 times 2 times 1, you end up with 120. Those are the different arrangements that can be made with the word. A jar containing only nickels and dimes contains a total of 60 coins. The value of all the coins in the jar is $4.45. Find the amount of nickels and dimes that are in the jar. So I'm going to set up 2 equations based on the information that's given. It tells me there are a total of 60 coins. So I'm going to use my variables N and D for nickels and dimes. So N plus D would be equal to 60 because that's my total. Now it also talks about the value. And since I know the value of a nickel and a dime, okay, the value of a nickel is 5 cents. So I'm going to put 5 in. And I know the value of a dime is 10 cents. So I'm going to put 10D. It says that the value in the jar is $4.45. And since I have removed my decimal points here on the value of my nickel and dime, I must do the same thing for my total value. So I'm just going to write it in terms of all pennies, which would be 445. Now, if you like to work with decimals, you can keep it in decimal form and you'll get the same answer. Now what I'm going to do is I see that I have 2 equations and they're set up in standard form. So I'm going to do the elimination method. You could solve the top one for either your nickel or your dime and do substitution. So it's your choice which one you want to use. So I'm going to multiply here, okay, because I'm going to cancel out my nickels. So I'm going to multiply by a -5 so that these can become opposite each other. So I'm going to put all of this in parentheses and multiply by -5. And I'm just going to come down here and write the new equation. So -5 times n is -5n. -5 times d is -5d. And -5 times 60 is -300. Now at this point, I see that I have 2 equations. I see that my n's can cancel out because they're opposites to each other. So now I'm going to just add my column for my dimes. 10 minus 5 is 5. 445 minus 300 is 145. And now when I solve here, I'm going to be dividing both sides by 5 here. Okay. So now when I divide, I see that I get 29 dimes here. And I need to know the amount of both. So I can go back to the original equation where it says there were a total of 60. So that means I can take 60, which is my total, and subtract my 29, and I'll get 31 for the number of nickels. And so, of course, you can always go back and check this. You can add 29 and 31 and get 60 for your answer. Or you can choose to use the value and plug them in to see if you get the same answer. But you should have 29 dimes and 31 nickels. Okay, for this problem, we are graphing 3 inequalities. So once again, I'm going to look at the first graph here. And I notice that it is not set up in slope-intercept form. It only has a number here, so it's missing my x variable. So in order to graph this, this is telling me that y is greater than or equal to negative 5. So that means the negative 5 will always be y. And in other words, all of the x's can change. So that means the x can be any number here, but the y will always be negative 5. And so how that graph is shown, it's shown by a horizontal line. So I'm going to draw a horizontal line going across, because what that means is y will always be negative 5. Now it has that line underneath it, so I made my line solid. But it also says greater than, so that means it can also be all the points that are above as well. So I'm going to kind of do a little lines here just to kind of show all of this should be shaded in. If you were shading in with pencils, color pencils, markers, or whatever, but all of that is shaded in. Now I'm going to go to my second inequality. It says y is less than or equal to 2x plus 5. Once again, now I have slope-intercept form. So my starting point is at 5 on the y-axis. So here's my dot for 5 on the y-axis. I'm going to go up to over 1. So I'm going to make my slope show the fraction. So I'm going to go up to over 1 and put my dot, down to over 1 and put my dot. And I'm going to see the direction that my line is going in. So I'm going to have a solid line again. So I'm going to go ahead and draw the solid line. And this time it says less than, so I'm going to shade below the line. Now remember, whenever you have a slant, think about skiing. If you're skiing, you're going to be on top of the slope, of course, so you will be here. So if I'm going to shade below that line, it will have to be everything on this side. So once again, I'm going to go in this direction now, just to kind of show you what it's looking like. Okay, so there's that line. Next thing we're going to do is the third inequality. Y is less than or equal to negative 2x plus 5. So once again, we are starting at positive 5 again, so that will be this line. There's the dot for that one. And it says negative 2 for my slope, so I'm going down 2 over 1 to the right. So from my starting point, down 2 over 1 to the right. I can also go up 2 over 1 to the left, and I'm going to see my line being formed. It should be a solid line because of that equal sign. So I'm going to go ahead and form the line here and kind of go out, draw that line, and it says less than. So this time I am shading below the line again because you're going to be skiing on top of the slope. And since I have 3 lines here, if I was doing 3 different colors, okay, on your graph should show your 3 different colors where they meet. That will be your answer to the whole problem. So this shape that is formed is a triangle. And I see that all 3 colors would meet right here. And then you will start seeing where there may be 2 colors over here, 2 colors over here, but 3 colors should meet here for your answer. So this would be your solution, this triangle. So on this problem, we're going to be solving the radical expression. And notice on the left-hand side, you have the radical subtracted by a term, which is 1. So in order for us to solve for x, we must get rid of the radical sign first. And before we can remove the radical sign, we must make sure that it is on the side by itself. And in this case, we must move our -1 to the right-hand side. So I'm going to have the radical here, which is the square root, on the left-hand side. And I'm going to move my -1, which makes it a +1. So I end up with a positive here, +1 minus 4. And that's going to simplify down to 3x under the radical, -3. +1 and a -4, or +1 minus 4 is -3. Now, in order for me to get rid of my radical, I must square both sides. So I'm going to use parentheses. And you want to make sure you use parentheses when there is a negative number, because that means that negative is included with that number. So when I do my square root and square it, the 3x comes from underneath the radical. And when I square -3, -3 times -3 is a +9. Now when I solve here, I know that x is equal to 3. Now this is a solution, and if you want to go back and check this problem, like normally we would, check our answers to make sure we're getting them correct. If I go back and plug in my 3 here, I'm going to get 3 times 3 is 9 here, okay? So the square root of 9 minus 1 is equal to -4. Now, when I take the square root of 9, that becomes a +3 minus 1 is -4, and 3 minus 1 is 2, which is not -4. So we do get some cases where there is a solution, and we call them extraneous. These would be extraneous solutions here because, yes, there is a solution to the problem, but this answer does not work in this particular problem when you're plugging it in. So you do have to make sure you are understanding. On this problem, I'm being asked to find the mean, median, mode, lower quartile, upper quartile, and interquartile range for a set of numbers. Now, this is data analysis, and this is what we do when we're trying to find as far as statistics. We use this information to help us for different reasons here. So we have 16 numbers here, and we're going to find the mean of those numbers. The definition for finding mean, which is also average, is to take the sum of those numbers and divide it by the total number of numbers. Now, in this case, we have here, we add them up. Notice you have some decimal numbers in here as well. So when I add these up, I'm going to get 131.5 when I add all 16 numbers up. That's my sum over my total, which is 16. Now, when you are dividing, you will not always get a whole number. Sometimes you can get repeating numbers, or sometimes you can get irrational numbers that are decimals that continue. And it may not even say in the directions what to round your answer to. My suggestion would be to look at the data, look at all the numbers that are given. If there are any decimal numbers, look at how they're written, and use that to determine how you should write your answer when it's a decimal number. So I look at my data here, and I see that I have some decimal numbers, and they are to the 10th place. So that means I'm going to round my answer to the 10th place. When I use my calculator and get my final answer, it is rounded to 8.2. So when I round that, that becomes my final answer here for the mean, 8.2. Now the median says to find the middle number. That is what median is. It's the middle number, but you have to have them in order. And you can go either from least to greatest or greatest to least. You would notice here that I took my 16 numbers and I wrote them in order from least to greatest here, because now I have to determine where my middle number is. Now to find the median, there are 16 numbers. There are several ways you can go in, like the first one with the second, and just kind of make your way going in until you get to the middle. This one with this one. These two will match up. 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 So that means my middle is going to be right in between those two. That's my middle number. And in this case, 8 would have to be my middle number there. That will be my median because between 8 and 8 would be 8. When you add them up and divide by 2, you get 16 divided by 2, which is 8. So you're taking the average when you have two middle numbers. So we have 8 for the median. Now I'm going to find the mode. The mode would be the most occurring number. So you want to look at your list and see which number appears the most times. Sometimes you may have more than one mode. That means you have some numbers that are appearing the same amount of times. Or sometimes you can look and none of the numbers repeat, so there's no mode. So when I look here, I see my 7, 1, 2, 3, 4 7s. And I see that there are 3 10s. So it looks like 7 will be the one that appears the most. So my mode is 7. Now I'm going to go to my lower quartile. Now, the definition for the lower quartile is you're taking the median of the lower half. So remember, keyword in this quartile, okay, think about a quarter, think about fourths. So we're breaking them up into parts now. If you remember, our median took our data here and broke it up into 2 parts, okay? So we have this half and this half. And now our lower quartile, we're going to take this half and divide it up again. So we're taking the median of the lower half. So this is our lower half and this is our upper half. So we're going to do the median again of the lower half. So once again, if this is our median here, that means we're going to start here with this number and match these two together, work our way going in, work our way going in, and work our way going in. We have two middle numbers again, 7 and 7. And I'm just going to put the line through that so I can see that's the median for my lower half. And of course, 7 and 7 is 14 divided by 2 gives me my 7 for the median of the lower half. So that's my lower quartile, which is 7. So I'm going to come here and write 7 for my lower quartile. Now I'm going to go to the upper quartile and I'm going to do the same thing. Now I'm going to take the middle number of my upper half. So once again, we can pair off if you want to do it that way. Pair off. You're going to see that 9 and 10 meet in the middle. So I'm going to take the average again. Between 9 and 10 would be 9.5. That's going to be your middle number between 9 and 10. So my upper quartile is 9.5. And of course, the interquartile range works just like the range of your data. If you're just trying to find the range of your data, you simply take the maximum number minus the minimum number, or the highest number minus the smallest number. That is how you find range. So if you're trying to find interquartile range, then you simply take the difference in your quartiles. Okay? So we're going to take the upper quartile, which is the U and the Q, upper quartile minus the lower quartile. That is how you find the interquartile range. So here I'm going to do the upper quartile is 9.5 minus the lower quartile, which is 7, and I get 2.5 for my interquartile.